Well, good evening and welcome to tonight's webinar, Winter Feeding Strategies. Tonight's webinar is presented by the North Peace Applied Research Association. Thank you to that organization for presenting tonight. My name is Caitlin Reeser and I am hosting the webinar. A couple of housekeeping items. If you want to ask a question of Barry, our presenter tonight, there's a question box that you'll see, and just type in your question and I will ask those questions of Barry as we go throughout the webinar. And also the webinar is being recorded. You will be sent a link via email tomorrow. So with that out of the way, I would like to introduce our presenter, Barry Yaremcio, Beef and Forage Specialist at the Alberta Ag-Info Centre. So Barry, I turn things over to you.
Thanks, Caitlin, much appreciated. Nora, thank you very much for getting this meeting organized or webinar organized for us tonight. And we should be through our slides, and with any questions that come along, please ask them as we're going along or type them in to be asked. And we should be finished in roughly an hour to an hour and 20 minutes as a rough guess. So Nora helped put this one along. Here's her contact information if you need to ask her about things after we're done the webinar or tomorrow. So there's her contact information, and we'll get into the main thrust of the presentation. I've got two rules that I try to follow when I'm balancing rations and providing nutrition to various types of animals. The first rule that I use is I try to provide the highest quality of feed to the animals with the highest requirements. That being the lactating cows, growing calves at that 400 to 500 weight range because they are young and just freshly weaned in many situations, and also for the bred heifers and first calf cows as well. So first calf heifers as well, because when they calve out, they're 85% of mature body weight, and they need to grow another 15% by the time they deliver their second calf, and they also have to get rebred and produce the milk. So they are definitely one of the highest requirement animals on the farm. Rule number two is you try to blend off feeds with different quality when you're feeding the animals with lower requirements, such as mature dry cows, herd bulls that are in maintenance and they're not working. That's when you can save a bunch of money and use up some of the less optimum feeds, or blending in some of the feeds that are straw-based or aftermath, things that don't have the protein and energy that you typically get with a good quality hay. Oh, sorry, missed one here. So what we're seeing this year as feed quality goes is with the abundance of moisture, lack of heat, lack of sunshine this summer, we're seeing that the quality of forages has dropped dramatically compared to the 5-year average. Protein is probably the biggest thing that I'm seeing as a reduction, partly due to the fact that a lot of the nitrogen that was available to the plant was leached down below the root zone of the plant when you get 30-35 inches of moisture. Calcium and phosphorus, those are basically dictated by the type of plants and nutrients within the soil zone as well, but acid detergent fiber is up by roughly 10 points. I use acid detergent fiber as a way to determine how mature the plant is. Fiber levels should be in that 30 to 35% range at 10% bloom, or at the heading stage for grasses. For every week that the plants mature past that heading stage or the start of the flowering stage, fiber levels go up by about 2% per week. So you can see that a lot of the crops this year were cut roughly 5 weeks later than normal because of weather or field conditions. In retrospect, when you look at acid detergent fiber levels, that's what's used to determine the energy content in the forage. And with the fiber levels going up, you're going to get a corresponding reduction in energy levels. So we went from 61, which is an average quality hay, down to 53%, which is basically halfway between a reasonable quality hay and straw. So supplementation is going to be a lot different this year than in other years. So what we want to talk about this evening is alternate feeding plans for wintering cows, including swath grazing, cereals, or corn. What happens when you put a liquid molasses protein product on straw bales, using low bushel weight or tough grains, wheat. What's the cost of protein supplementation, including urea? Uh, what mineral or what protein to use and when? The vitamin supplementation, and then the use of tubs, protein or mineral types. So we'll cover those, and if there's questions as we go along, please let me know and we'll discuss them as we go. So swath grazing is something that tends to work very well in most parts of the province. Exceptions are those with high levels of wildlife where the elk and the deer take more feed than what the cows get, or if the snow gets above the height or the depth where when a cow puts her head into the snow, it's above her ears. At that point, they stop grazing. So with the cereal crops, oats, barley, triticale, winter wheat, uh, these crops are all deficient in calcium and magnesium. So if they're cut at the proper stage, the material should have adequate amounts of protein. And when I say proper stage, oats at the late milk to early dough stage, barley early to mid dough, probably about a week to 12, 14 days earlier than when you'd cut that barley for silage. Triticale, it's a cross between wheat and rye, tends to have a higher fiber level than the oats and the barley, but it's a critter on its own because you want to cut it a little bit earlier because of the high fiber levels, but I've heard it too many times that when people have cut the triticale between heading and before there's any milk in the heads, what happens is there's some sort of a taste or something that causes the cows not wanting to eat it. So if you're cutting triticale, you must have some sort of kernel fill. So if you squeeze it between your thumb and your finger and all you're getting is milk, you need to let it mature just that little bit more. So even a quarter kernel is enough for you to cut triticale, then it's safe. Wheat, again, higher fiber levels, early to mid dough stage as well. Now, a lot of people are trying to use a 1-to-1 or 2-to-1 mineral when they've got them out on a straight forage swath grazing situation, cereal swath grazing, and that's not enough. You need a minimum of 3 parts calcium to 1 part phosphorus, and preferred is a 4-to-1. So something in the range of 20% calcium, 4% magnesium is typically what you want in that type of mineral. So there are companies that are putting out a swath grazing mineral or a corn grazing mineral. And if those aren't available, the other one you can look at is a feedlot type mineral and just adjust and just modify the amount of rumensin in that product if it's at high levels for feedlots. Grazing corn, something that tends to be catching on across the province. It's a learning experience right now, no different than what happened when bale grazing was first introduced or swath grazing was introduced a number of years back, because corn's a different critter. It's something that's a lot different than the oats or barley for grazing. You can see by the composition of the leaf, the cob, and the stem, most of the nutrients occur in the cob and the leaf. The stem, I would say, is no better than wheat straw for quality. Now with the late gestation cow, if the cob has formed and you've got a milk line on the kernels that are about halfway down the kernel itself, you should have enough energy to make it through late gestation, but definitely not enough for a lactating cow. This is part of the reason why you only want to graze on a 3-day rotation with beef cattle. The first day, those cows will eat most of the cobs and a lot of the leaf material. High energy, reasonably good protein levels, so they're going to get what they need. And then on the later half of the second day and into the third, after all the leaf material is gone, they have to clean up the stems. So if you have this up and down momentum of the corn supplying lots of energy and then less energy, you want to keep that variation to a minimum. People that let the cows out there for 10 or 15 or 20 days without moving a fence, they might be fine for the first 5 or 6 days, but after that, they're short of energy, they're going to be losing weight. Protein, on the other hand, the cob and the leaf, again, have the highest level of protein. The stem or the stalk, back down to 5%, no different than straw. So if you do put these cows out into a patch for 12, 14, 15 days without moving them to fresh material, they're definitely going to be short of protein. And one of the ways to watch that is when you do have a lack of protein in a diet for a beef cow, what'll happen is rumen bacteria are not able to digest the fibers as good as they should be, and the manure, instead of it being a nice flat pat or patty, you can start seeing it to peak up like a pyramid. The sides or the parts of the patty will be rough in texture, and that's a good indication when you're running into a protein deficiency. This year, with there being a lack of heat units and a lot of the corn crops that I've heard about, they didn't even have a cob developed this year. So one thing, your yield is going to be down dramatically, and number two, the cob makes up roughly 50% of the dry matter per acre. Therefore, you're relying on the leaf material to supply the protein, and you're going to be short faster because there can be a greater percentage of stem to leaf, and the three-day rotation may be enough to cause a problem as well. Molasses supplements on bales. It's something that comes up in discussions every year. People want to improve the intake of straw by enticing them to eat more. And unfortunately, limitations for molasses or for feed intake is dependent on neutral detergent fiber content in the forage. Once they eat 1.2% of their body weight in NDF, they stop eating. They are full. So what happens when you apply molasses to a bale? The application rate, I talked to 3 or 4 different applicators that are around, and the range was any place from 70 to 100 pounds per round bale at 1,000 pounds. And the cost was roughly 25 to 30 cents a pound. And for ease of conversation, I'll stick with that 25 cents a pound. So if you're putting on the 70 pounds of product, it's $17.50. If you're putting 100 pounds of product on, you're adding $25 to the cost of a bale of straw. And around here, straw, barley straw, oat straw was selling for roughly that $25 a bale as well. So you're doubling the cost of feeding the straw. With the limitations of NDF, another way I look at it is a cow will eat any place from a 1.25 to 1% of her body weight in straw per day. So a 1,400 pound cow will eat a maximum of 20 pounds of straw. So if you're feeding 50 cows, they should clean up that bale of straw every day. And if they do that, they will be getting someplace between 1.4 and 2 pounds of molasses per day. Limitations of intake by NDF content in the diet, and also what is the total protein content in the ration. So this is a label that I've had on my files, and as you can see, it's a 32% protein supplement. Nothing wrong with that, but the calcium, phosphorus, and magnesium levels are extremely low. And the reason for that is when they register a product with the Canadian Food Inspection Agency, they have to have the same percentage or concentration of the nutrient from the first tub to the last tub, or from the first leader and then the last leader out. If they're out by 5 to 10%, they don't get the registration. So in order to register the product, those three ingredients, calcium, phosphorus, magnesium, not being very soluble, they don't stay in suspension very well. That's why the levels are as low as they are. Trace minerals, on the other hand, usually pretty good to keep in suspension. Same with your vitamins, and it tends to work reasonably well on that situation. So if you're feeding the 20 pounds of straw right off the start, your straw typically is roughly 4.2% protein. If you add that 1.4% pounds of molasses, your protein levels goes up to 6.4%, which is not sufficient for an animal in mid or late pregnancy, let alone after calving. And then if they go up to 2 pounds a day intake, then they are right at the borderline, 7% being the borderline for protein. You can see that it has met the requirements for the cow in mid-pregnancy. Energy levels, virtually no difference. Calcium, phosphorus, magnesium, you'd expect very little change as well. Where you get your big increases is your salt intake. 0.25% in the diet is what you require. So at 2 pounds a day, you're getting more than double the amount of salt that cow requires on a daily basis. It'll entice her to drink a little bit more water. Other than that, shouldn't be any problems. Now, if we look at the trace mineral levels, you can definitely see that there's improvements there. They all look reasonably good, except for vitamin E. I like to see vitamin E levels for a cow in mid and late pregnancy at 300 IUs per day. We're only getting 90 at the 2 pound range. And then after calving, that vitamin E level should go up to 500 IUs per day. Cobalt and iodine look just fine. So you can see that straw being a short of calcium and magnesium by what we talked about with the cereals used for swath grazing. Same thing applies here for the bales of cereal straws, low in calcium, low in magnesium. You're going to need extra energy, so roughly 12 pounds of barley, 13.5 pounds of oats, plus 0.3 of a pound of limestone, 0.04 pounds of magnesium oxide, a little bit more salt if they are not getting a product with salt in it, and then again some more vitamin E, 50,000. Free choicing a 1-to-1 or 2-to-1 mineral will not work, and my recommendation is mix your limestone and magnesium and vitamin E in with the grain and feed it into a trough or some containment system. If you throw the grain on the ground, you will lose 90% of the vitamins and minerals that you're adding to the mixture. Feeding lightweight grain. The University of Alberta did some research back in the late 80s, early 90s, and they compared 34, 47, and a 51 pound per bushel barleys on feeding background and finishing steers. That was the original research that was done. They also did a little bit with cows, pregnant cows, and basically it was in these rations. They tried it as steam rolled or dry rolled barley, and again 10% alfalfa grass hay to provide the roughage in the diet. So what they found was when they looked at the different bushel weights and the tough or damp grains, the higher moisture content increased the size of the kernel. It became swollen. The pericarp or the hull on the outside of the barley was pushed away from the starch matrix that's on the inside, and what happens is it basically improves the digestibility of the product. So instead of getting 12 to 15% reduction in digestibility, if with a dry grain, the tough or damp grain, you can expect that digestibility to improve by 5, 6, 7%. So you can consider the tougher damp barley to be the same digestibility as what you get from dry whole oats. So using the high moisture grains at the higher, when it's frozen, tends to shatter. If you drop an ice cube on the floor, you can see that the ice cube shatters. Same thing happens with the grain if it's hit by a hammer and going through a screen, or if going through a roller mill, you'll have more breakage to that kernel. So you might have to widen the gap in the roller so that it's not as severe for damaging the kernels and causing more fines. And for hammer mills, if you can use old hammers and old screens so that it's not quite as sharp and not as aggressive. And the other thing you can do is with some of the older mills, you can slow the tractor down to 1200 RPM so that you're not getting that force of impact on the hammers or the screens, and you should have barley that's going through, or cereal grains that are going through with less damage. If you want to double check what you're doing, the processed grain should be 75% of the original bushel weight, and that is a good indication that you're doing a good job. You might see a few kernels that are coming through whole, but the objective with any of these grains is you want to split the kernels in half and no finer than that. Now, with the results from the feeding trial, apologize, these two slides are out of order. They're backwards. What happened with the lighter barley, just a second here. Anything that was heavier than 42 pounds did not have any difference in performance with the backgrounding and finishing steers, and same with the cows. So if you can find 42-pound barley, the discount that I'm hearing from the feedlots is they start applying a discount at 46 pounds, number 2 barley if it's going to the elevator, and at that point they'd apply a $5 per ton discount, and then the feedlots will drop another $5 per pound under that 46. So that lightweight barley at 42 pounds could be $25 a ton cheaper, or roughly 50 cents a bushel cheaper than something that's heavier weight. Digestibility is the same. The animals did very well on it. They maintained their rates of gain and feed conversion efficiency. No differences in carcass quality, yield, or rib-eye area. So it's something to look at if you've got feed grains in the area that are tough or damp, and you know you can buy it at a discount and use it up before it gets warm next spring. It's an opportunity for you to save a few dollars on your winter feeding program. Wheat in cattle rations, this is a little bit of a different scenario. Same will apply for triticale. Wheat is a much more rapidly digested feed grain than barley or oats. With that, your chances of having problems with acidosis and bloat increase. And if you do not roll the wheat, you will lose 25% digestive efficiency when it's dry. You should crack the kernels into 2 pieces, and that's it. If you've got a few that are coming through whole, I'm okay with that, because if you try to make it finer than this and make it look more like chicken feed or pig feed, you're going to have problems with bloat, acidosis, or grain overload. Now with dry grain, your maximum inclusion rate for wheat in the ration is 6 pounds a day for the mature cows and 3 pounds a day for the 700-pound feeders. If you've got the high moisture grain that is not rolled, you could probably go up 2 or 3 pounds more over that. But anytime you're including wheat in the ration, start at a couple or 3 pounds and increase it 1 pound every 2 days. If the manure looks good, then you can increase it again. So the trick to the feeding wheat or any of these grains is watch the manure. If it's soft and sloppy and wet and you can see a whole bunch of manure and the back end of the cows are dirty or the back end of the feeders are dirty, that's telling you that the rumen is not happy. Too much acid production, you're going to need to back off the grain until things settle down. Now, there's a feed value estimator available on the Beef Cattle Research Council website, that beefresearch.ca. And what it does is it compares the relative value of different grains based on the protein and energy content. So what they use for an option here is barley at the current value, either on a per bushel or per ton basis, based from getting prices from your local market. And they use canola meal as your protein source. So they take the energy value from the barley and then the protein content from the wheat. So if you're looking at buying different types of cereal grains, what's a good deal and what's not a good deal? So we're using barley as the standard in this chart, 12.5% protein, 83% TDN, and relative value, that's your constant or your standard at $3.81 a bushel. Feed wheat at the higher protein, higher energy content. Feed wheat was at a $6 discount against barley here last week. So it's undervaluating at that current price. It undervalues the amount of energy and protein you're getting for that wheat, and that $14.30 or 40 cents a bushel is a premium that you can afford to pay and still get the same value as barley on a pound for pound basis. Oats, on the other hand, lower protein, lower energy again. The price off of the weekly price review with Alberta Agriculture was $9 higher than barley. And with that in mind, you're paying 37 cents or $24 a ton more than what you should be compared to barley. Corn, lower protein by a considerable amount, and the price at $214. If you were buying corn right now at $214 a ton, you're paying $44 too much for that material per ton. Triticale, again, higher protein. I couldn't find a price for it on the market. I just assumed that it was the same price as barley, and you could afford to pay $19 a ton more, or 45 cents a bushel more than what the current price is. So this is one of the two calculators that came up on the Alberta or on the BCRC website, and it's nice to use it to see what's available. If you can get that 50 cents a bushel discount on your barley, put the values in there and see what it does with the calculation. So it definitely makes it a lot easier to see if you're getting a good price or not getting a good price. Any questions so far, Caitlin?
Not at this point, Barry. Just a reminder to our participants, if you do have a question for Barry, just type it into the question box, address it to me as the organizer, and I will ask questions. But right now, Barry, we don't have any, so I'll let you carry on.
All right, sounds good. With the lower quality forages this year, be it hay, green feeds, silages, one of the things that really needs to be looked at is supplemental protein. And 4 different types that we can get. Feed peas, it's a good source for on-farm. You got canola meal, you got your lick tubs, and then you got your commercial 32% supplement. So any of these can work, but what are the ups and downs, or what's the advantages or disadvantages of the different types of protein supplements? There's the different feeds. If you're close to Lloydminster or close to some sort of processing plant, I know there used to be a canola mill up in Sexsmith, or crushing plant in Sexsmith, which would have made it nice for canola meal. But a lot of these supplements are reasonably good in protein, 20 to 30%. Liquid stillage, something if you had a consistent supply at 48% protein, would do a really good job. Calcium values are usually low, and which is normal for the grains, but the one thing that does happen is your concentration of phosphorus in what's left over after the milling process has happened is those values are can traditionally double to triple what you would find in barley grain. So for example, barley grain is usually 0.4 or 0.35 to 0.4%. You know, when you look at wheat distillers at 0.96, that means you're going to have to add even more calcium to a straw grain diet using the wheat distillers as your protein source. So that's something that needs to be, you know, worked out through Cowbites or working with Nora or one of the forage associations or your nutritionist or the feed mill people you're working with, or even this is what I do here at the Ag-Info Centre as well, is, you know, what needs to be put together so that you do get a balanced ration going into those cows. So how do we calculate what's really a cost-effective source of protein? And I just took an example of canola meal and field peas. Peas, 30 or field peas, 24% protein, canola meal, 38%. You've got a cost differential from 305 for the canola meal versus 230. Which is your better deal? What you need to do is calculate the number of pounds of protein that you have per ton. So for example, the canola meal, 2,204 pounds times 38% gives you 837 pounds of protein. Divide your price by the number of pounds of protein, you can see that it's 36.4 cents per pound. Field peas, on the other hand, only have 24% protein as an average. If you're looking at that, you're only getting 528 pounds of protein per ton. Divide your price by the number of pounds, and it's 43.5 cents. So you're looking at about 7 cents differential per pound of protein going into these calves or into the cows. So that makes a big difference. Now, I have heard that some of the areas have peas that are a lot lower in quality than what they'd be paying for this 625 a bushel or 230 a ton. If there's lots of discoloration and a bunch of tag on the peas themselves, price could be down by 50% or more. So redo the calculation with your current prices in the area to determine what works well. And you can't just look at the cost of protein per pound. You need to look at what the impact is for getting the feed into your farm. So canola meal from Fort Saskatchewan to Grand Prairie is about $35 a ton for additional freight. So if you take that $35 a ton divided by 837 pounds, you're adding your 4.2 cents to the price that you had. So once you factor the freight in, there's not much differential between the peas and the canola meal. Peas, just as an aside, as long as the cows are able to crack the skin on the pea and it breaks into two parts, they will do an excellent job of digesting them. So, you know, let them chew, let them do what they can do, and they should do a good job instead of you having to put them through a roller mill or through a hammer mill. This is something that I'm seeing a lot more in the industry right now, especially with things tightening up. There's always some sort of product out there that is new on the market and is supposed to do everything. So product X was being advertised as a single source of trace mineral supplementation to meet the requirements of the animals on an annual basis. So for example, the 950-pound heifer would get 6.33 milliliters per dose, 4 doses per year at a cost of $13.42. What do you actually get for that? We have to take a look at the label. And I'll just pay attention to the copper right now. There are 15 milligrams of copper per milliliter in this supplement. If you give that 950-pound heifer 4 injections of 6.33 mils, that animal will get 379 milligrams per year. Sounds pretty impressive when you look at it that way, but what does it actually mean versus their requirements? So the 950-pound heifer will be getting roughly 1.04 milligrams of copper from the injections on a daily basis. The requirement using cow bites, and that was based on the NRC for beef, they require 150 milligrams per day. And if you look at the manganese and zinc and selenium, you can see that the amount that these animals are actually getting are negligible. So if you relied on that and only fed a blue salt, even though you're getting roughly half of their daily requirement from the forages and grain that's being fed, that still leaves them half deficient. So this kind of a product is something you've got to be careful of. If you're not sure, send a label in to me or to whoever you want to chat to and say, okay, is this going to work for me or not? And in this situation, unfortunately, when the salesman comes and gives you the spiel on this kind of stuff, watch his nose. It tends to grow because this stuff just doesn't do the work that it's supposed to do or what the claims are. Protein lick tubs or blocks, they work great in areas and situations where it's later in the growing season and you've got no other way to supplement with additional grain or hay to bring the product up or bring the protein levels up. They do a pretty good job, but anything that is offered free choice, you may see that the proper number of tubs or the right number of pounds, even if it's a mineral salt combination, you can see that the right amount is being consumed on a weekly basis. But how do you know if the animals are getting what they need? There will be the boss cows that'll get more. There'll be the timid cows that won't get as much. So there's no way to tell what's happening there. And therefore, what are they actually receiving and what's the cost that you're looking at? I pulled a couple labels off out of my file again. Got the new cost indications from the manufacturers. The first one, not a bad product for what they can do. 30% protein, 5% calcium, 3% phosphorus. So that's quite a bit higher than what you had in one of the previous slides that we looked at there. Intake 500 grams per day at a cost of 82 cents. Not bad for supplying the protein. You're getting a reasonable amount of some of the trace minerals, or the macro minerals aren't too bad. Trace minerals are good. So this one, yeah, for 82 cents a day, it's doing a reasonable job. The second product, a 22% product, again, 450 grams of intake. You can see that the calcium and phosphorus and magnesium levels are much lower than the other product. And how you compare the two is you multiply your concentration by expected grams intake to give you how many grams they're going to get per day. And you can see that the the nutrient content that the cows are getting from this product is not as good, and the cost has almost doubled up to $1.44 per head per day. So it's something that really gets expensive in a big hurry. And are you really getting what you need? That's where feed testing comes in. Do the rations with Nora or whoever else and get some advice on what do you actually need to balance the ration. Vitamin supplementation this year is going to be critical, with hay being cut 5 weeks late, being raked 3 or 4 or 5 times, being rained on 5, 6, 7 times. All your vitamin precursors for vitamin A and vitamin E basically have been destroyed by the weathering process. In a normal year, you can get 100% of the precursors to be lost within 90 days of cutting. In this case, I would suggest that all the vitamins were lost, vitamin precursors were lost by the time those bales were made or when the silage was made. If you're looking at silage, be it round bale silage, chopped silage, the fermentation process destroys all the vitamin precursors that are available. So you have to start feeding the vitamins immediately with silage every year. And in this year, I would suggest that instead of waiting till the last 2 months or 3 months prior to calving, start feeding your vitamins now. Yes, it is an expense, but the number of calls I have had in the last 2 years with sick or dead calves within the couple 3 days after calving, poor reproductive efficiency, cows not cycling, a lot of that we could trace back to the problems they had with the vitamins in the ration. Feeding the cow, what does that animal actually need when they're out either swath grazing or if they're being fed in a pen? Rules of thumb that I use, and these levels are a little bit higher than what you'll find in the NRC because our animals are out in the weather. There's wind, there's rain. They have to adapt to the temperatures. Therefore, they need a higher protein level than what's recommended in NRC because those animals are in perfect environmental conditions at 70 degrees Fahrenheit under a barn when they do the testing. So pregnancy, mid-pregnancy, late pregnancy, and after calving, 7, 9, and 11% protein, and energy 55, 60, and 65%. So you can see that from the previous slide about the quality of hay that we're seeing this year then compared to last year, the hay is just barely going to meet protein and energy requirements for that mid-pregnancy cow. And usually from the samples that I've seen, there are very few that will work in late pregnancy and fewer yet after calving. So we're going to try to take a look at some different rations and associated costs along with this. So cows in mid-pregnancy, we're going to assume that the hay and silages are of the same quality, 8% protein, 57% TDN, and the straw at 5% protein and 45% TDN. And the reason I'm using the same values is there's a lot of producers that have made bale silage or chopped silage this year that have never done it before. And how do you look at the feeding rates when there's a difference in moisture content between the three different products? Hay at 15%, the chopped silage is at 65% moisture and 35% dry matter, and the bale silage is any place from 30 to 50% moisture or dry matter, depending on what you're using. So option number one, you can go ahead and feed 28 pounds of hay, 3 pounds of straw, and the limitation on the straw is due to the total amount of neutral detergent fiber that that animal can eat. 1/4 pound of limestone, 0.03 pounds of mag ox. You need your vitamins and trace mineral salt with selenium, and you should get a 3.3 pound expected daily gain on this ration. And I've used that 0.3% or 0.3 pounds of average daily gain to be the standard across all the rations. Now, if you don't have the hay, a straw grain ration, mid-pregnancy, late pregnancy works very well. So your 20 pounds of straw, 10 pounds of barley, oats being 10% lower in energy and 10% lower than protein compared to barley, you know, with the standard varieties, the Caliber, Cascades, Jasper, those rules apply. If you're using the SO2 or the Nasser oats, they're the high energy levels. You can get away with the same number of pounds, but you're still going to need a little bit more protein. Again, limestone, magnesium oxide, trace minerals, and vitamins, same amount. So that will work. Option 3, just want to show you how much difference there was or there is between the various rations. So in the previous slide, you're feeding 28 pounds of hay you'd need to feed 50 pounds of chopped silage and 10 pounds of straw when you've got a product that's 65% moisture. And if you look at round bale silage with 40% moisture, you reduce your feeding rate to 32 pounds because cows need to eat dry matter. The amount of water in that feed is just so much less water that they're going to drink or less snow that they're going to eat off the ground. So it works pretty good. With the higher energy requirements and stress because of cold weather, when a cow eats, she can produce enough heat to keep herself warm down to -20 because of the heat of fermentation. Once you get it below that -20, they need extra energy to keep warm, keep them out of the wind, keep them bedded down, also help reduce the loss of heat to the environment. So if you're feeding 4 pounds of grain at -20, then at -30 at noon, you need to go up to 6 pounds. And if we get a real good cold snap at -40 at noon, you need to bring it up to 8 pounds a day. Watch the temperatures, watch the weather forecast. When you hear that you're a day or two ahead of a warming trend, start pulling back that grain at that point so that when it does get back to -20, you're back to 4 pounds of grain. Because cows can't take off their fur coats. And if you are still feeding 8 pounds of grain at -20, they are going to produce a lot more heat. They're going to overheat and have heat stress in the middle of winter, and they're going to back off on the total amount of feed that they're going to consume on a daily basis. So late pregnancy cows, again, 1,400-pound animal, -20. The big difference in energy and protein requirements between mid-pregnancy and late pregnancy is that 75% of the calf growth occurs in the last 3 months of pregnancy. The other thing that happens in late pregnancy is colostrum is formed any place from 6 weeks to 8 weeks prior to calving. And in order to have a good quality colostrum, you need the protein to produce the protein in the rations so that you can build the quality of the colostrum. And the other thing, only way that calves can get vitamin E is through the colostrum. It is not transferred through the milk. So, same conditions as what we had last time. You can see that the 28 pounds of hay and 3 pounds of straw, what we've done is we've taken the straw out completely. You need 2 pounds of barley and a pound of canola meal to bring your energy and protein levels up to what's needed. A little bit limestone, magnesium oxide, trace minerals and vitamins again. The straw, your limitation is still 20 pounds of straw a day. Your barley grain stays at 10 pounds, but we're adding an additional 2 pounds of canola meal. Now, the difference between a hay ration and the straw grain is your canola meal and the barley is adding significant amounts of phosphorus to that ration. Therefore, you need 3/10 of a pound of limestone per day per cow. Some people try to mix the grain and the vitamins and minerals together. Works great as long as it's fed into a trough. If you're using a wheel or some sort of delivery system that puts the grain mixture on the ground or on the snow, you're going to lose between 80 and 90% of the minerals and vitamins that you're supplying to the cows. So if you are feeding the grain on the ground, put the mineral and vitamins into some sort of tub and have them eat enough supply enough in the tub or your salt station so it's 3 or 4 days and it's gone. Keep it fresh. That way your vitamins don't oxidize off when it gets wet. Option number 3, you've gone up to 70 pounds of silage. Again, you need the barley and the canola meal, same as the other rations. And if you're looking at a 40% moisture content instead of 65 pounds, you only need 45 pounds of round bale silage. After calving, your nutrient requirements of that cow go up 25% the day that she starts to lactate. Using these products again, it's going to be a little bit tougher, but that 8% protein is probably someplace close to what we're seeing right now. So 26 pounds of hay is about the maximum you can feed, along with 10 pounds of barley and 3 pounds of canola meal for the hay ration. Some people last year ran out of feed and they were forced to use a straw grain ration after calving. It's something that I do not recommend because it takes a lot more effort and a lot more management. You cannot put 20 pounds of barley or 22 pounds of oats in front of a cow at one time without expecting to have problems with acidosis and bloat. So I'll leave that one alone and say try to do something different and leave the straw grain rations for pre-calving. The chopped silage, you're up to 75 pounds of silage for the chopped pit silage or pile silage that's been chopped. Again, 8 pounds of barley, 3 pounds of canola meal, your limestone magnesium, and then instead of 75 pounds of chopped silage, you're down to 44 pounds of round bale silage with, again, the barley, the canola meal, limestone, and magnesium. So why am I making such a fuss at looking at the different types of ration? Just, I'm going to use some numbers that I obtained from our economist here, and what they're telling me is hay's going for 140 a ton, or about 7 cents a pound, straw at 45 a ton, roughly $22 to $25 a bale, silage $60 in the pit, barley at $3.81 a bushel, and canola meal at $3.05. And then I talked to a couple farm supply and feed mills. These are roughly the cost for the limestone magox, salt, and vitamins. Didn't find a price for the vitamin E, but after this presentation was made, found that about $90 a bag. So $2.25 a kilo for, about $3.50 to $4 a kilo for the vitamin E. But you're only adding, 8 or 10 grams a day per head. So it's not that big of an expense, but the value is definitely worth doing it. So if we look at the cost per head per day, your straw grain ration is almost 70 cents cheaper per day compared to this all hay ration. In mid-pregnancy and using the silage, you're about 30 cents cheaper than a straight hay ration of 7 cents a pound. So here's an opportunity. If you're feeding your cows in mid-pregnancy for 90 days and you've got 70 cents a day difference in cost, that's 63 bucks. Late pregnancy, the differential is about the same. So there's another 70 bucks. So if you go with a straw grain ration prior to calving, or if you find a way to buy grain that's tough or damp, that differential will be even greater. So you can see that looking at different feeding options, and even though you have to buy in more supplements or more grain on a overall period of time, it's still definitely cheaper than going straight hay. And at the lactating cow, I'm not recommending the straw grain ration. And in that case, with the hay ration, $3.19 a day versus $3.47 for against silage, you can see that there's ways to cut your winter feeding costs. And Dr. Hughes, back in the late 90s from the North Dakota State University, he was an extension economist, and he found out that for every dollar that you can reduce the feeding costs for an animal over the winter, it increases your profitability by $2.40. So that multiplier effect is probably larger now with higher land and equipment and operating costs. So anything you can do to save your dollars when you're feeding is definitely going to pay you big dividends in the long run. Feeder and background in calves. This one's a little bit more complex and more difficult to do a ration for, because you've got the different sizes, different weight gains. But what I look at when I'm looking at either a backgrounding or replacement heifer ration, there's no place for straw in these rations. Second thing, if you're using a 65% pit silage, you need to add other ingredients to bring the moisture content down below 50%, because for every percentage of moisture above 50%, dry matter intake will drop by about 1/6 to 1/3 of a pound of dry matter per day. Protein is critical because it's needed to build bones and muscle. It helps develop the animal to its genetic potential, so it does frame out properly and does have the size and structure that you need for it to be welcomed at the auction market or for an animal that you want to have as a replacement. I'll talk a little bit about protein. Again, these high rates are a lot higher than what NRC recommends, but John McKinnon at the University of Saskatchewan basically found that if you use 10% protein for a 1,000-pound animal, that'll meet requirements. And for every 100 pounds lighter weight that you have on that animal, you have to increase the protein content by 1%. So if you're feeding 500 calves or if you're weaning 500-pound calves, the overall protein content in that ration needs to be at 15%. I can't really say much about the energy because, are you looking at 1.5 pounds a day gain versus 2 pounds versus 3 pounds? 3 pounds is a little bit outrageous for backgrounding, but again, if you're looking at the replacement heifer at puberty, you do not want her gaining more than 1.75 pounds a day because she will put down a lot of fat in the mammary tissue or in the udder, and she'll have limited milk production capabilities for entire life. So you don't want those replacement heifers to grow too fast. Protein and feed intake, the negative feedback loop. So let's say you're short of protein in the ration. What'll happen is the bacteria, some of them only have a 20-minute lifespan. They need to populate or repopulate the rumen to digest the fibers. And if they don't have that critical number of bacteria or microbes needed, the rate of fiber digestion goes down and there will be more fiber resident in the rumen for a longer period of time, which in turn reduces your voluntary feed intake because the animal is full. Once you get the reduction in feed intake, you got that negative feedback loop, which causes the protein level to be reduced again from what there was on the first day versus the fourth day of feeding. And if it continues on without any compensation to get extra protein in those animals, impaction is a possibility. Very uncommon, but it is possible. Feed waste is something that should be considered when you're looking at your feeding programs. Buskirk in 2002 looked at about 7 different types of feeders, and what they found is losses were any place from 3 to 15%. The ones that were the best at that time were the ones that had a holder or a cradle up above a regular round tombstone feeder, so that bale was supported at a 45-degree angle. The animals had to reach in through the bars, and if they dropped any feed, it landed inside the feeder. Some of the work that we did in for feed waste as feed delivery systems, unrolling long hay on snow, we lost 13% of the hay by weight. Using a bale processor, this hay was 90% meadow brome and 10% alfalfa. We got 19% waste. The second year we tried feeding chopped pit silage on snow. There was a calculation error by the person delivering the feed, and they were only getting about 60% of what they required, and they were still wasting 23%. On a full feed ration, I would expect that number to be someplace in that 30-35% range. Long round bale silage fed on snow, 23%. Work done at Lakeland Applied Research in 2012 at the Bonnyville location using bale grazing, they got 19% waste. If you're looking at storing feed, putting them into a pyramid is probably the method that will create the most damage to your hay. So this is a perfect example of a winter where we did have some snow. The snow would have been on top of these bales within the last week or so. Nice warm temperatures, all that snow has melted. And where does it go? It goes in between those bales, and everywhere those bales are touching, that's where you're going to get the deterioration in quality in black colored hay. If it gets bad enough, you could get some, and the temperatures stay warm, you could get some caramelization and further reduction in quality throughout the entire bale, not just where they touch. The mushroom stack, the picture in the middle, a lot of the hay is stacked that way. The top bale generally has very little damage, but the bottom bale, it'll wick up moisture from the ground and also from the water that runs off the top bale into the top of the support bale. So it's better than the pyramid, but still not great. If you're going to know that you're going to have a little bit of feed left over, you want to have bales laid out in single rows. Leave 6 to 10 inches in between the bales so they're not touching. That minimizes the amount of damage to that product. If possible, going ahead and investing in a shed or using a tarp is better than having the bales uncovered, unprotected out in the weather. But sheds do cost some dollars, and tarp bales typically have a notorious habit of tearing and not being good for using them for more than a year. So it does get expensive that way as well. So in conclusion, feed testing is probably the one strategy this year that will definitely pay back for what you're doing. I know that Nora's got some core sampling tools up at the office in Manning. Walk in or phone ahead, book them, and get them ready. If you're from some of the other areas, most municipalities do have them available at the county or the MD offices. So it's something that you can do, or get a feed salesman out to help you with that task. Feed inventories match the number of cows to what feed you have available. And it's not just enough to know that I've got 750 bales of hay. What's the quality? How do you mix and match the hay that you have from the different fields to meet the animal needs? And that's where you need to balance the ration. Ask for help. If you're not sure what you're doing, or if you're feed testing for the first or second time and you're still not sure what those tests say, call us and see what you need to do for getting into extra information. There's always a need to evaluate the costs when you're putting a feeding program together. Everything has a cost, but what product can you use, or how do you combine products to give you the most effective ration and minimize your cost? So it's a balancing act, and don't be afraid to ask for help. That's what we're here for. My contact information, if you want to talk to me directly, my phone number is there, along with my email address. If you want to send me your feed test results by email, be more than happy to chat with you over the phone and figure out how to discuss the results and put numbers together for you. And with that, Caitlin, I am going to shut it down and turn it back to you.
All right. Well, thanks so much, Barry. We do have a couple of questions for you. The first question is, will cows eat a 1/4 pound of limestone free choice?
That is the $1,000 question. Limestone is very dusty, chalky tasting, pulls the moisture out of your mouth. And it's not that I can speak cow. I worked in the feed mill for almost a year when I was a lot younger, and I only made the mistake once of not putting a dust mask on. Magnesium oxide, on the other hand, is extremely bitter. So again, both products do not tend to be well consumed by a cow-free choice. You can improve the consumption by mixing it with the salt. The other thing that can be done is add about 7 to 8% dried molasses into the mix so that it sweetens up the mixture and entices them to eat more. But if you can put your limestone in with the silage or in with the grain and force feed it in a bunk feeder or a fence line feeder, that's probably your best way to do it.
All right. Before I ask the next question, just a reminder to those of you participating, if you have a question, just type it into the question box, address it to me, and I will pose that question to Barry. So Barry, the next question is, what is the best or cheapest source for vitamin E to add to the existing mineral and vitamin mix to get it up to needs?
The only source that is available for on-farm mixing is vitamin E 50,000 IUs per kilogram. The product that they use at the feed mills is 500,000 IUs per kilogram, 10 times stronger than what you can use on farm. So that's about the only source that you have. I'm not a big fan of injecting vitamins into cows. I'd rather see it fed for two reasons. When you inject the vitamin, you may have great numbers or great titers in the blood for the first 30 days. The label will probably say, you know, your injection will last you for 90 days. The first month, generally lots, and that curve will peak and start coming down. So by about day 45, they're not getting enough for what they need. And that goes for, you know, the AD injectable and the injectable E. The vitamin A and D only has enough vitamin E present to prevent the oxidation of the vitamin A and the vitamin D. So consider that to be virtually zero.
Okay, thank you for that, Barry. And again, if you have questions, please type them into the question box. While we wait to see if there are more questions, Barry, I'm just going to turn it over to Nora Polovich, who is the manager of the North Peace Applied Research Association. And Nora, do you have any comments or questions as we get closer to wrapping this up?
I'd just like to say thank you very much, Barry, for sharing your knowledge with us once again and getting the word out to people who you are and what your contact information is, just so they know that there is help out there if they're struggling and trying to figure out how to feed their cows this winter, and that you can help them balance a ration. I also have Cow Bites, which is what Barry, the program Barry uses. So if you'd like to give me a shout anytime, we can work through it. And Barry is always there as our backup resource. So thanks again, Barry.
All right, well, thanks very much, Nora. And I'd also like to thank Barry, and I'd like to thank the North Peace Applied Research Association for presenting the webinar, and Barry for taking the time this evening. Barry, we don't have any further questions. Do you have any final comments?
It's going to be an interesting winter to feed cows with the low protein, low energy levels. Just because everything went well in previous years, this is one year where if things aren't done properly, come February, March, you're definitely going to see thin cows and run into calving difficulties with weak calves or cows that just won't milk enough compared to what they should be.
All right. Well, thank you for that. Thank you to those of you who participated this evening. Thank you for your questions. And a reminder that you will be receiving an email with a link to the recording if you want to watch it again, or if you want to pass it on to someone who was not able to attend this evening's webinar. So thank you, Nora. Thank you, Barry. Thank you, participants. And I hope everybody has a great evening. Thank you.